So quinine absorbs strongly at 350 nanometers. So our excitation wavelength can be set to 350 nanometers. I'm going to collect my emission spectrum from 360 nanometers on to about 600 nanometers. So that's going to be fine there as the stop wavelength. And I'm going to click OK. Those are set. I'm going to start, name my sample so I can find it more easily. Click OK. And the scan begins. So what you'll see on the y-axis is intensity in AU. In this case, that stands for arbitrary units. You'll notice that the arbitrary units go up to 1,000. And in our spectrum, what you can see is that we've essentially maxed out at 1,000 arbitrary units on our y-axis for much of the spectrum. Quinine emits so much light. It's very strong, has a high quantum yield of emission. So in our setup, we had our excitation slits at 5 nanometers and our emission slit at 5 nanometers. I'm going to close both of these down to 2.5 nanometers. And I'm going to click run again. Call this quinine 2. You'll notice that a second spectrum is added. And now our emission maximum is capping out at maybe 150, maybe a little bit more arbitrary units. But the nice thing here is that we can see the entire spectrum. The scan has completed, and it shows that the emission maximum is at 456 nanometers. So what happens if we change the excitation wavelength to, say, 300 nanometers? Let's do that. And let's scan from 310 nanometers out to 600. Let's call this quinine 3. Again, adding another spectrum. We can make this bigger. Let's take this little dot. Okay, you can maybe see that there's a little bit. There it is. Okay. You see the spectrum showing on the screen. And again, this is showing an emission maximum at 455 nanometers. So I would say that that's the same. What if we go to 250 for our emission and 260 for our start, 600 our stop? Let's try this. (456 nanometers). Okay, so let's take an excitation spectrum of quinine. Let's monitor our emission at 456 nanometers. That was the maximum of our emission. Let's start the scan at, what's our lowest? We can go down to 190. Let's go to 200 nanometers and let's scan up to 400 nanometers. And start. We'll call this excitation. Quinine. Okay. Not sure why the graph's not appearing. Oh, no, it's right here. So there's an excitation spectrum for quinine.